This video will discuss the solution to question 20, which goes as follows. What is a good approximation of the negative 3 dB frequency? And that is the negative 3 dB frequency of this entire amplifier. Now the first step in this process should be reminding ourselves that we applied this millicapacitance to push the pole associated with the node of V out to higher frequencies and the node associated with the output of stage 1 to lower frequencies. So we should find the pole frequency of this node here. Finding that pole frequency first requires us to compute the time constant in this node. And the time constant again is just the product of the resistance in this node and the effective capacitance in this node. Let's start with the resistance. The resistance in this node is just the resistance of Mn2 in parallel with the resistance of Mp2. So if we apply the given values, that will be RON in parallel with ROP. And if we then use the values that have been given to us of 20 kilo ohms for ROP and 5 kilo ohms for RON, this resolves to 4 kilo ohms. The next step is finding the effective capacitance in this node, which is the millicapacitance, which then has to be multiplied by a factor to compensate for the Miller effect, because Cm lies between two nodes of an amplifier. The amplification factor from the output of stage 1 to the output of stage 2 is G.M. N, namely the transconductance of transistor Mn3, multiplied by the output resistance of the second stage, which again is the resistance of Mp4 in parallel with the resistance of Mn3. So that is RON in parallel with ROP. That's another 4 kilo ohms as calculated here above. If we fill in the values given in the caption of the figure, that means that this capacitance will be 21 times the millicapacitance. To now find the dominant pole frequency, we just have to take the reciprocal of our time constant. And if we now also want to find the absolute frequency, we just have to divide it by 2 pi. The result of this will be approximately 2 megahertz. And that is the correct answer.